Hello, everyone. Good morning, good evening, good afternoon. Thank you for joining us today. This is Turing's webinar on building the foundations for AI readiness with myself, Miller Truby, and Turing CEO Hiep. I'll do some proper introductions in a few moments here. This is the second session of this webinar, primarily geared toward our Asia Pacific time zones. We did this earlier today for our North American time zones as well. Had some great content and some great questions. So looking forward to doing this again and serving the rest of the world. A few housekeeping items before we get started today. The webinar will be about 45 minutes of content plus a 15-minute Q&A session at the very end, along with our closing thoughts. The session is going to be recorded. Replays will be available to everyone who registered, whether they show up live or not. So for everyone who is looking to share this around with colleagues who may not have been able to join today, you will be able to do that. Our dial-in participants and watchers will be on listen-only mode during the presentation. That will allow us to present without interruption. However, we do have for the Q&A, there is a chat feature on the right side. At any time, we encourage everyone to go in there, type in questions, comments, things that you think you want to hear discussed more. And when we get to that Q&A session at the end, we will choose the best comments and make sure they get in for the Q&A. And if you see something posted in there, you can also upvote that. That helps us to choose which ones will be highlighted when we go to the Q&A session toward the end. With that, we'll do some quick introductions. Our primary speaker today is Hiep, CEO for Turing. So Hiep is a pioneer in this digital water solutions space. Many of you likely know him or know the name. He has 26 plus years of experience in the water treatment industry. That included, of course, leading the development of our current TopClear platform that we're going to be talking about quite a bit today. Previously, Hiep worked as the CTO for Gradient and was responsible for the development of the SmartOps AI platform that Gradient uses, as well as the RO Infinity product line. He holds multiple patents in his name throughout his career and was named as an emerging leader for the International Desalination Association. So we very much appreciate having Hiep here and talking to us all today. Myself, I'm hosting today as moderator. My name is Miller Truby. I am the customer success manager for Turing. I've got about 20 years of experience in the water treatment industry, primarily supporting operations groups, troubleshooting, technical services, sales in some cases, lots of commissioning and startups of large-scale systems under my belt. Right now, as customer success manager, my primary job is to help utilities and industrial customers to deploy our TopClear product and helping them to really modernize and get to the point of optimization and compliance. I won the Outstanding Leader Award for SWAN recently and was very humbled to receive that award in Berlin. I also host the Fluid Operations podcast for Turing, along with my co-host Kirk Wessel, which is a very fun project for us where we get to talk about sort of the philosophy of bringing tech into the water industry. So hopefully that will be something that people want to listen to. So before we hand things over to Hiep and talk a little bit about the actual content today, I want to give a little bit of background on who Turing is and why we hope folks will be interested in working with us. So our vision, our goal at Turing is really to build AI-backed systems that truly understand water treatment, water collections, water distribution. We have built up and spent a significant amount of time and effort bringing on board individuals with significant subject matter expertise in the water treatment industry and pairing them up with a really talented development and data science team that has decades of experience with machine learning, generative AI, and even agentic AI, trying to build a team capable of building products that can deal with some of the very complex water infrastructure issues that we see. And to that end and to that goal, we have really built an end-to-end flexible data management sort of process that we employ. So we want to be able to have this product integrate seamlessly across any type of system that's out there, any control system, any suite of sensors that you may have, We can do various different types of deployments with this product, whether that be fully air-gapped on-premise deployments, private cloud, public cloud, and any combination thereof. We've really endeavored to build a flexible system so that this can be deployed in as many places as it possibly can, while still maintaining the highest level of cybersecurity protections and protocols. And then, of course, we want it to be a holistic system. We want it to be a single platform, a single source of truth that can bring together data and information and insight from a whole bunch of different sources, including SCADA systems, maintenance systems, inventory management systems, health and safety and environmental quality systems, training platforms, all of the above, and tying that back to being able to power that with artificial intelligence insights that, the AI doesn't sleep, it doesn't take breaks, it doesn't go on vacation, and we think that's really powerful. So the purpose of this webinar today is really to set the foundations for getting to that point. That certainly is the point that everyone's trying to get to, but there's work that has to be done before you can get there. So we're going to talk about what it takes to be AI ready today, what practical steps can be taken for both industrial and municipal users to transition from traditional standard O&M practices into a more data-driven and potentially AI-enabled operations as we go into the future. We think that's really important, and we think making sure that people do their due diligence and are aware and educated of how to take these steps is really, really important and something that we should be investing in and investing our time in. So very happy to have everyone with us today. We hope it'll be great. As I said, feel free to type those questions into the chat anytime they come up. And with that, we will hand things over to Hiep Lee to take us through our content. Hiep.
Thanks, Miller. Good day, everyone. Thanks for joining. We'll start with understanding, the goals that most of our customers, when we talk to for using AI, this includes, summarizing performance insights, detecting problems early, so pretty much beating the alarms and doing things about it before the alarms occur, and then lastly, optimizing energy and chemical consumptions. So a lot of our customers and get excited about the AI capabilities and what can do. But what we also find that getting the right data to go into the AI algorithms to generate these insights to achieve these goals is challenging. So we'll talk through more about that in the future slides. Some of the realities in the industries we see from a report that studied use of data by Dodge Data Analytics talks about the struggles with data management. The good news, water utilities and other customers understand, the value of data, and in fact, 80% of them gather data digitally, whether it's in some software platform or spreadsheets. But the challenge is 50% of them or half of them believe they're only capturing half of the available data to be beneficially used. The other struggle is 90% of them report data as isolated in various systems that are disconnected. So data silo is one of the big challenge. And one of the critical challenges coming up is really, more than a third of the workforce in the water industry is eligible for retirement by 2030. This leads to, a potential loss of knowledge and being able to bring the next generation of operations, engineers and technicians to do the good work in the water industry and provide, safe and secure water for the population. So they being able to use data and AI is a set of tools that will elevate, the workforce, not replacing people, but actually helping them do their job and preserving the knowledge better. So let's explore why these data problems haven't been able to be solved, broadly across the whole industry. It's because it's quite complex and there's quite a large amount of data, and there's barriers, both technical, organizational, and as well as the security and compliance. So if we look at technical barriers, with the systems that most of our customers have, right? So for example, a SCADA system was designed to control pumps and valves, not interface with different other systems, including, say, a spreadsheet to be able to analyze data. The computer maintenance management, CMMS, is good at tracking work orders and scheduling, the technicians to do the maintenance, but it's got no idea about what happens in operations in real time, as well as things like water quality data. So in fact, each system was chosen to solve a specific problem, and each one does its job well. That's been designed to, but they were never designed to talk to each other. So they have multiple communication protocols to interface with as well. In terms of organization barriers, it's also challenging with the risk aversion of going to cloud deployments. The IT team, generally small in water utilities, much larger in industrial customers, but they all have competing priorities against the business objectives. And then there's also, with data, there's huge amount of data. There's also unclear ownership of how to solve that by who. And I mentioned about security compliance. That's very, very important in water, because cybersecurity is not just an IT issue. It can become a public safety issue for the water utilities, and a production sustainability or security for the industrial facilities or customers. So what we understand, the average water facility uses multiple disconnected software systems, typically 3 to 5. So, from the SCADA to LIMS, the CMS, and eventually the ERP system for purchasing and inventory management. And each of these software systems speak a different language. So the challenge is how to bring it all together.
All right, thanks, Hiep. And that brings us to our first interactive poll question. So I'm going to bring this up on the screen here, and you should see a poll pop up. And we are curious to hear, what do you consider your biggest challenge, your biggest data challenge, I should say, today? Possible answers here: my systems don't talk to each other. Data is siloed. Don't trust my data quality. Reports take forever to create because they are manual. Worried about cybersecurity risks related with data and data sharing. Not enough skilled staff or budget to perform the tasks that are required to either gather that data or analyze it potentially, or of course, all of the above. And we'll let folks have about a minute here to consider and make their answer. While they are putting their answers in, Hiep, I think both you and I, with our experience in the field over our careers, have sort of seen all of these different scenarios at different plants. Is there one of these that you think of as being more prevalent among the plants that you've worked on or worked with? Or is it really an all of the above situation from your point of view?
I think from a customer perspective that we've spoken to, most of them is all above. But from my personal experience, going back probably 15 years ago when I was operations, including operations management, and very remote sites, I say there's not enough skilled staff or labor is a key area, which also elevates the importance of being able to use data effectively, and having data at your fingertips to do the job quicker and better.
Absolutely, and that trickles down to all of the other things that are on here. I think you brought up that stat of 41% are sort of approaching that end of career retirement age, and I think that trickles down to, if you don't have the staff available, then you maybe also don't have data that you can trust, because you don't have people doing maintenance that's required to keep those instruments up and running. You may have more and more work required that's manual, that then takes up more and more time for new people, and it's a steep learning curve. So yeah, I agree with you. I think that's kind of a linchpin piece of the puzzle here. So seeing votes trickling in here, looks like results so far kind of split between my systems don't talk to one another in the data silos, and then folks saying all of the above. A couple of people answering don't trust data or worried about cybersecurity issues. So I think that kind of lines up with what we were saying. A lot of it feels like all of the above for the plants that people are working with. So thanks for those who have taken the time to answer that. We very much appreciate it. I think we will move on to the next part of the content now. So Hiep, back to you.
Excellent. So let's explore what the ideal future looks like for an operator, operations manager, etc. as part of the operations team. So in designing our product, we had imagined this is one of the scenario. So on Monday morning, you walk in, from the weekend, and within 5 minutes, you better see your complete operation status on intuitive dashboards with minimal clicks. So you know right away, what's happened in the last week or on the weekend, and be able to address it. So all relevant data instantly available, insights are visible from historical context, and you know the trending patterns forecasting of what will happen. The other aspect is all your reports, last week or the weekends or overnight, are automatically generated, ready for you to review, and then send on to management or compliance authorities like EPAs, etc. The other aspect we see very useful is predictive alerts for the potential issues that I mentioned. Being able to forecast and predict a future point for a certain trend is a critical part of using AI, and that allows you to be able to schedule your maintenance and any other operations adjustment by the condition of the actual equipment itself, not by guesswork or just time based. So we see that's an important future ideal situation. And how do you achieve that? Is by getting good data and as well as deploying the right algorithms in terms of AI. So one of the statistics we found from a software company that did some research on water professionals, that 3 days out of every up to 6 weeks are spent on checking data quality and ensuring that it matches the sensors, it matches whatever the process, and doing something about it. So that's wasted time that could be spent on more high value tasks, such as optimizing the plant and ensuring compliance for public safety. So let's look at the steps that you can take to establish a good foundation for data management that leads to deployment of AI products or algorithms. So the first step we advise to take is do a treasure hunt, a data treasure hunt. So know what you have. So look at your data sources, such as the operations data from your SCADA system, the maintenance data, work orders, and historical equipment failure from your CMMS, water quality data from your LIMS, or laboratory information system, or spreadsheets or PDFs, as well as business data from your ERP system, such as your purchasing, your inventory, and your operating cost. So these are important categories of data, and the assessment questions you ask are shown there. So in terms of how data is stored, what's the frequency of update, whether it's real time from a SCADA system, who uses data, how do you access it, and how reliable is data, and do you have any validation to ensure that the data is accurate. And also the system, each of these systems share data electronically, or you have to do manual batch filing system, which can automate it as well. So what's surprising that most customers, when they do that, and I've been in this situation when I was doing operation, is that they discover that the valuable data sources they forgot that they had, including historical data from old sensors that are archived, which can also be very useful for tuning your AI algorithms and giving it better context for its performance and future forecasting of certain failures or patterns. So step two, which is the important step for automating, this data management process, is how do you make your systems talk to each other? So you can see on screen, we've developed TopClear as the glue for all your systems. So from the left, you got the important SCADA system that transmits real-time data. So how do you integrate that? So there's various protocols, such as the OPC UA, which is think of that as a universal translator for your SCADA and other OT systems. There's also the Modbus and DNP3 legacy system as well, protocols that we can also interface with. We also have on top, spreadsheets and paper. We can ingest those as well, which are important for a lot of customers that are still going through the digital transformation journey. And then at the bottom, the other software systems, they generally have either an APIs or we have an access to their database, or in the worst case, they can output files, which we can do automated batch processing. So once we ingest that, then we can run AI algorithms or just statistical analysis to provide, the dashboards that give you the insights at your fingertips.
Perfect. And that brings us to the second poll that we are going to ask our audience here. And sort of following up on those first two steps in this process that Hiep has highlighted, we want to hear about thinking about your current system. Which of these integrations would really provide the most value, the most quick return on investment, in your opinion? So that could be a SCADA system being integrated for more operational, for automated operational reports, something like a CMMS system, integrating maintenance data with performance metrics for asset management purposes, lab data being integrated automatically for the purposes of reporting and potentially regulatory reporting, or all systems being integrated into a centralized platform to sort of bring everything together into a single source of truth. So again, as people put their answers in here for their specific cases, the one that always catches my eye here, Hiep, is the integration of lab metrics for regulatory reporting. I think that's something that's come up a few times with customers that I've spoken with. I think it's a really interesting and potentially useful idea that really potentially brings a new use or some new use cases for that lab data that currently is difficult to use for AI processes. Do you agree that there's a field to be explored there?
Definitely, I think that's a good point, and one that's often overlooked as inputs to the AI algorithms. Because from my experience with designing water treatment plants, water chemistry is quite a key factor in being able to design that plant properly, as well as ongoing operation and maintenance. So being able to input those regularly and automatically into the AI algorithms gives it, additional context to better, look at the performance of the treatment process and be able to optimize it, and or be able to ensure that you're complying with the treatment water quality objectives.
Yeah, and especially for municipal users, that regulatory compliance is an absolutely critical path thing. If they can't get that, they can't run the plant. So I could see why that would be compelling for some folks. All right, seeing answers once again trickling in. Seems like most answers for this one are all systems going into a centralized platform to get all that data together in one place, which that sort of lines up with what we know and does line up with, I think, the first steps that we're talking about. First step is, what do you have? Can you get it all together in one place? And then you worry about the analytical aspects of it. We do have some people answering the SCADA integration for automation. Would also be valuable, which I think is kind of the first step in that all systems together in a central platform. So that makes sense. Once again, thanks for those who are answering the poll. We very much appreciate it, and it helps to guide us for what to talk about here. With that, I think we'll give things back to Hiep to take us on to steps 3 and beyond in this process. So Hiep, back to you.
So yeah, step 3 is keeping the data secure. One of the things we've sort of focused on is our ISO 27001 certification, which we achieved last year, and this allows us to set up processes for information security management. So it's important. Security concern is quite valid and critical in the water sector because of that public health aspect, but one that can be solved. It's quite overwhelming for the non sort of IT people. I'm a chemical engineer myself, so when I first looked at security, it can be quite overwhelming. But I think if we can break down to simple terms, I think it can become a bit more digestible for the operations team. So first, with any process to harden things is to do a risk assessment. So we would do that risk assessment with our cybersecurity experts using the 3 core principles of cybersecurity in terms of network separation, encrypted connections, and access control. So I explained that in a bit more simple terms. So some of the steps you can take is to establish software firewalls and via virtual private networks to separate the networks from the operations network with a SCADA system against your business network, which is your work, the ones where you use your ERPs and your emails, etc. And then create secure tunnels for your data transmission into the cloud itself. Second sort of steps that you take is role-based access control, so setting up the roles. So in our platform, we have 8 different roles, from all the way from the viewer to the super administrator that can do everything. So that you set up for operators to see operations aspect and views, and then managers see more summaries and more advanced, and then administrators to their config and set up reports and other aspects of the customization. And as you deploy the data management, the audit trail is important. So you track who has accessed what data and when, to ensure that there is the legitimate access to that data and you're not being hacked. And then also another important point is to better regularly update all the software with security patches. This starts from your operating system, your laptop or your computer, to the software you use, and any other additional automation you deploy for this data management. So what can be surprising is that automating and hardening your cybersecurity provides or reduce the risk of human error, and provides the better tracking through the audit trail for your data management. So that's something that it becomes a bit more evident as you do this, setting up this data foundation. So step 4 is the last steps before you take the AI transformer journey, is the make your data trustworthy. So here on screen you see the 6 pillars of data quality. So what each means, I'll go into a bit of that detail. So it's important that you have accuracy in your data. So what accuracy means is your sensors tell the truth through regular maintenance. So whether it's a pH sensor, you do cleaning and you do calibration to ensure it's reading accurately. You have to have automated validation rules. So maybe a surrogate measurement of another sensor or a duplicate sensor to ensure that the reading is correct. It's also with our AI algorithms, you can have outlier detection. So then, if there's an odd, pH reading, then it's a problem. Second is having the data complete. So it means having all the information you need and no missing data. So then you don't have to do assumptions. So that's been able to capture all the data, ensuring that you have redundancy, as well as having certain algorithms to fill in the gap when it's missing. Maybe you had sort of electronic signal interruptions. Uh, Third is being consistent. So that means that everything speaks the same language across all systems. So, example is being able to standardize all the units, ensuring that timestamp is uniform, particularly when you have a remote user. So you have a local timestamp and a remote user timestamp to understand the difference. And then lastly, consistent naming conventions and format for being consistent. Fourth is the data needs to be timely, so it means information arrives when it's useful. So if you had a lab result that arrive a week later, then you actually made the adjustment, then it's not really relevant, is it? Uh, for fifth is being unique, so you make sure that you have one single source of truth. What's that authoritative source for each type of information? So that means you have to ensure that any conflicts can be resolved through rule-based algorithms and other sort of AI algorithms. And lastly, relevance. So it means your data serves a purpose. Against the business objectives, it supports KPIs that you have, and as well as support all your decisions from the whole facility itself. So what often gets overlooked is how much it impacts, if you have poor data quality. So the hidden costs of longer troubleshooting time. I've been in that position when I was, managing the operation and being able to provide the right report to our customers. So a lot of troubleshooting time. You also can have suboptimal operations, regulatory compliance issues, as well as when you make a decision, it's some that can be guesswork, which is not low confidence type of decision making. So once you establish a strong data foundation, so the next step is to take the AI deployment journey. So here is an example of what that could look like for a membrane treatment plant in utilizing reverse osmosis. So you can see on screen there to your left, this is when you have disparate or silo data. So you're in reactive mode where you are firefighting a lot of the time. So from a membrane cleaning perspective, a lot of our customers follow the O&M manual from the OEM or equipment builder. So they clean membranes every 30 days or, for more cleaner water every 90 days, regardless of the actual condition or performance itself. Then once you get the data and you can do the insights or even statistics before even AI, you can engage, the proactive mode. So this is where for membrane cleaning, you can clean membranes based on your trend, such as the different pressure or salt rejection or permeability, so that you're actually fouling is occurring, and you can clean based on that condition itself. So you're less overwhelmed now from the reactive. You're a bit happier. But the ultimate goal, really, of the AI sort of optimization is to be in optimized mode. appears where you're smiling with, and be able to predict, fouling based on feed water quality forecasts, based on a diurnal or seasonal, as an example, and be able to optimize your cleaning, chemistry and timing, including your concentration, the time you soak, etc. So the AI can help predict that based on, being able to program in our experience in the field.
Which brings us to our third poll question that we wanted to ask the audience. So now that we've kind of gone through all of these steps, want to talk a little bit and hear a little bit back from you folks about where you think you rate your own facility or facilities that you work with as of right now on this sort of ladder of reactive to proactive. So potential answers here: mostly reactive, meaning responding to problems only after they occur, doing maintenance by schedule. Partially proactive, meaning maybe having some monitoring in place, a little bit of condition-based maintenance in place, making repairs only as needed. Mostly proactive, having good data integration and taking a preventive approach to most issues that you would see at the plant, except for maybe major unexpected failures. And then that last one, it would be working toward that optimized state that we all should be working toward, where you're using analytics and prediction for some of your processes in an automated fashion. So would love to hear where people think they are on their own facilities. It's definitely interesting to hear the different answers and the different states. I know it's one of the things that is interesting about looking at the differences between the industrial and municipal sectors, and Hiep, I think you feel the same way. When we start talking about having the resources to really become proactive and then optimized, so many of the utilities, especially here in the United States where I'm based, just small utilities that don't have the resources to do this and that are really stuck in that sort of reactive cycle where everything is always on fire. Does that sort of translate around the world as well? Do you think that translates to other places?
Yes, that's what I've observed is most of our customers, when I visit plants, is between the mostly reactive to partially proactive state. A lot of that is dependent on the type of the labor they have, the ability to get data at their fingertips, and also the knowledge of the operators, and the experience as well of the operators itself. So yeah, our goal is really to bring everyone towards the optimized state, where no longer they feel overwhelmed. I've been in a position of being on call 24/7 for a whole week, and the thing you dread the most is to be called in the middle of night, to be woken up, or in the weekend when you're sort of resting.
Yeah, that the number of the auto dialer becomes your least favorite one to see on your caller ID screen. That's for sure. Quite a lot of folks answering here. Nice spread of answers. Kind of an even spread between the reactive and early proactive stages, and a few folks saying that they're mostly proactive and even working toward that optimized state, which is great to see. And that is reflective of good management, I suspect. So nice to see some folks who are taking those steps already. As folks finish up putting their answers in here, I'll just remind everyone in the chat, feel free to put in your Q&A questions. If there's anything specific you want to talk about, we will have the full 15 minutes here. I will stop the poll, as I think most people have their answers in at this point. And Hiep, we got about 5 minutes here to run through a success story that we are very proud of, and we think really highlights a lot of the steps that you've talked about today in getting a treatment plant that's in a unique situation really up to speed and able to use these AI tools that we've built. So I'll hand things back over to you to take us through that, and then we'll get to the Q&A.
Yeah, let's look at the real world success story where data can be managed well. So this is a remote operation case study. So if you look at understand the challenges, this is a remote site with high labor costs. The water source being groundwater is challenging with high TDS brackish and temperature up to 55 degrees. From what before we came in, what we understand is the existing plant has limited sensors and low availability, and the operations team was constantly firefighting with filter changeout and membrane cleaning. So that's the challenge for us. And part of our rollout of the full holistic view, we replaced the plant with an upgraded process design and increase the sensors in our design of the plant. That enable the team to do remote monitoring control with 24/7 support. The other aspect that is also important to be able to maintain the equipment is the monthly maintenance visit. Just as the maintenance, the operations allows up to this day to better automate the reports for our customers on a monthly basis. So the result of being able to send data, to collect data, send data to the cloud, and we got the checking mechanism in the cloud itself, and automation for our reporting and data collection. We've been able to save the customer compared to the previous slide, about 50% in labor. We increased the availability, so the downtime is normally about the trips, the power supplies issues, as well as any CIPs and filter changeout. But more importantly, the customer was quite happy with our production compliance, and we've been able to meet the capacity required and the water quality 100% of the time. So that being able to establish that strong data foundation and being able to access it remotely and be able to remotely monitor and control the plant has delivered the value to this customer, even without any AI involved.
Yeah, it's a great success story, and one I think we're all very proud of. And I just want to highlight too, while we've got a minute here, I think a big part of this particular story is this treatment plant really doesn't have the option to hire full-time operators out at this incredibly remote site that is very difficult to get to and very expensive to have people staying at 24/7. So for them, being able to apply an AI platform that can help them avoid needing operators like that, and it's, as we talked about, the lack of availability for really skilled operators really has a domino effect on all the other problems that we see talked about, and it's been really important for this site and really successful to deploy these tools. All right. Thank you very much, Hiep, for the presentation of the content here. I think at this point, we will move on into our Q&A session we're excited about. People have been putting some good and interesting questions in the chat here as we have been talking just over the last few minutes. So we will jump into those. So I think the first one that I want to highlight, this comes to us from Mark. And Mark asks, is there a solution for a local AI solution which does not require data to exit a utility's secure network?
Yes, that's a good question, and one we've had experience with where we've deployed to the semiconductor industry. So what we've done there is a full on-premise air gap solution where we set up the hardware computing power on site to better run the AI and machine learning on site for that case to better optimize water production in terms of water recovery from a membrane process, while also keeping the energy and chemicals optimized. So it's possible. We've done it, and it's something that we offer to certain customers that need that level of cybersecurity and don't want to approach the cloud sort of a deployment route.
Yeah, and it's as we said in the early parts of this presentation, we've made every effort to build a really flexible platform that can deal with these sorts of issues, can be deployed both on premise and air gapped as well as on the cloud. But we know there are always going to be some customers, whether they're utilities or industrial users, who are going to require us to use either private networks or secured networks, or straight up just avoid the internet altogether. And we will do everything we can possibly do to accommodate that. Okay. Another great question that has come from Saiganesh. In older plants where sensor coverage is sparse, how do you bridge those data gaps so that you can still get to the point of using AI-driven insights?
Yeah, that's another good question, and we've dealt with some of these plants. So I guess the ideal situation with this plant with minimal sensors is to better capture the local sensors, the pressure gauges, the rotameters on the regular basis, and digitizing that. So instead of capturing on paper or spreadsheet, you can enter those recordings on our platform. It captures right away into our cloud. We also have an app coming soon that we can use the phone's camera to also instantly use computer vision to record the reading of that pressure gauge or rotameter. That way you also can check the data quality, because often when you have local readings, sometimes the operator could make a mistake through oversight. So as long as you can enter the data into our platform, then we can run the algorithm to generate the insights. Even though it's not real time, it can still provide you enough insights to enable you to have better decision making than having no data management and being everything on paper or spreadsheets.
Yeah, and getting people away from that, post-it notes on stuck to a computer screen is absolutely critical to this, and it is exactly why we're doing this type of webinar, to talk about sort of how to bridge that gap and how to take those early steps so that you can have success when it goes to time to actually deploy these things. Okay, we're going to switch gears a little bit here, Hiep, and I'm going to throw at you I think, very technical question, and one that is certainly beyond my knowledge here. So this comes to us from Somi, or Somi. I hope I'm pronouncing that wrong or correctly. I apologize if I'm getting it wrong. They ask, how is semantic layer, data lineage, and knowledge graph important for AI, for efficient AI capability? So I'll let you dig into that one, and hopefully you understand exactly what's being asked there.
It's a great question from someone, I think, who understands the modern sort of AI architecture. So knowledge graph is something that we have in our we're working on to really increase the efficiency of the AI algorithms. So one things we do well as a company is that we're not just AI engineers or data scientists, but we also have chemical engineers that have the experience, including myself. So we develop we have the knowledge in terms of design and operations, so that gets embedded into a database, that knowledge graph, so that the AI algorithms can refer to that, particularly cases where the plant is encountering a new scenario that it hasn't seen in its history of operations. So it can seek this knowledge and be able to help with its decision making in what actions to take next to optimize or to correct, the plant performance. So setting up that architecture and being able to pass data to also develop new knowledge is what we also focusing on as well. So eventually, when we have enough, once we establish the data foundation for our customers, and then set up, that streaming of data, we can, create that, better knowledge graph over time, and our AI algorithms in performance will improve over time as well.
This is why it's wonderful to have a CEO who is a former CTO and can handle answering questions like that. I'm glad you understood that one, Hiep. Okay, another great question here. This one coming to us from Hanson, asking, how effective is AI to optimize energy or chemical consumption in membrane operations in real world? And I think asking, have there been any success stories or case studies we can point to or talk about in that specific area?
Definitely. I think what our experience shows that in, say, seawater desalination, which, if you understand seawater desalination, the power consumption or energy consumption is 60% of the OPEX. So a majority of it. So our work in seawater desalination with multiple plants is being able to reduce the energy consumption up to 5% in seawater desalination. And for a large plant, that can actually translate to $1 million of savings, per year. In terms of chemical consumption optimization experience, so that we have both a semiconductor as well as a wastewater recycling experience in municipal. So in semiconductor, we created scaling saturation modeling. We coupled that with water quality sensors upstream, like hardness, silica, fluoride. We were able to, tweak the anti-scalant dose rate to prevent the scaling. So we save, chemicals there. The other aspects of chemical saving is once we're able to predict the CIP, when you actually need the CIP, you can actually extend your intervals between CIP, longer than, actually using the triggers from the membrane manufacturer. In that way, reducing the CIP frequency also reduces your chemical consumption.
Yeah, and I'll just add in there on that one, that applies as well. I think people, when they ask about membranes, they often are thinking of reverse osmosis membranes, because that's been the sort of oldest or older membrane technology. But that same optimization concept has been applied by us very successfully in the UF and MF hollow fiber, and it's the same concept. If you take that holistic approach that we're able to take, and really understand the fouling mechanisms that are happening on that membrane, you can then go toward optimizing the process step time and reducing the amount of CEB or CIP chemicals that are necessary, and really realizing real chemical reduction improvement over the course of the life of those membranes, which can be very long in the case of modern MF-UF membranes. So we've taken that same approach, whether it be spiral wound RO membranes or hollow fiber membranes, and had some really good successes with that. Okay, probably time for one more question here before we wrap things up, and we're going to highlight once again Sai Ganesh. Can AI be effectively used to reduce energy consumption in high load units such as blowers, pumps, digesters, and how does that work? It's something a little bit different from the sort of membrane processes that I think we are initially known for. So Hiep, do you want to talk a little bit about how those high load units differ maybe, or can they be successfully optimized?
Yes, they certainly can. We start with more process, which is the digesters, for example, aerobic digestion process, such as conventional activated sludge. So this is where we can model the wastewater treatment process, the biological digestion process, and be able to infer back to how much air you need. And of course, you got sensors like DO in the plant. So once you have those in place, utilize the data, you can run the algorithms to optimize the aeration. And when we've seen, we like to work with water utilities to optimize this, but what we've seen in industry is that you can actually optimize up to 35%, energy savings. So that's for, activated sludge processes. In terms of, rotating equipment that are motor driven, like pump and blowers, definitely you can also optimize those, whether they're in the plant itself or in a pumping station on the networks. So you can track, the algorithms can track, the pump curve and the system curve. And, in a multiple pump system, it can, be able to optimize how many pumps should be operating on its best efficiency point, thereby, you're saving the cost. So basically, you're using AI algorithms to be able to automate what an engineer could do if he was going to sit there and fully focus on, manipulating the pump to its best efficiency point.
Yeah, and I think part of that optimization as well, especially when we're talking about pumps and pumping stations, things like that, it's not just the day-to-day optimization of how you run that pump necessarily. It is also the asset management side of things, keeping that pump in its best state of maintenance so that it does not drift off of its curve. Because one of the, if you're looking at energy consumption, one of the easiest ways to reduce that energy consumption is make sure that pump is always running at its most efficient capability. If it starts to drift, you got to be able to predict that that's happening and take proactive maintenance measures like we were talking about earlier. And then that goes back to having really good data in place so that you can do that, so that that pump is always operating in its most efficient possible space. And that is, a key component of that sort of energy reduction when we talk about these high load, single units or train units, pumps and blowers and things like that. Keeping them in their efficient space is a highly effective way of making sure that they don't use more energy than we want them using. So, a great question, and yeah, thank you. All right, that's probably coming to the last few minutes here. All we have time for in terms of questions. Thank you for everyone who participated here and fed us great topics to talk about. We want to end off today with sort of a final call to action and sort of summary of what we see as the steps that we can advise that our end users take. And that's, even if you're not our end user, just in the industry in general, as we go toward some of these tech advancements that everyone is looking at and talking about. So if we could sum it up, it is make sure you have that data inventory done, the data treasure hunt, as Hiep called it. Make sure that you're being honest about what all your data sources are, whether they be SCADA, third-party CMMS systems, LIMS systems, things like that, handmade spreadsheets, Post-it notes, sticky notes, logbooks, whatever that may be. List out those data sources and make sure you're aware of where all that information is stored and where it's coming from. Then you can do a pain point analysis to identify what those time-consuming or frustrating processes are, especially when they're around reporting and getting information sort of transitioned from a data source over into a actionable report. Find where those pain points are and be honest about the things that cost time for your team or yourself. And then once that's done, once you really understand what your pain points are, we recommend doing what we've been calling integration mapping. But think creatively about what those data connections could be that would help you to reduce those pain points. So once you've pinpointed what that pain point is, think about what you would need to exist in order for that pain point to no longer be a source of frustration for you. And that may help you to guide you to the questions you need to ask toward a vendor like Turing about what products are out there, what solutions are out there, and what can be done to reduce those pain points and get you something that makes it so that you can really automate and take that next step toward the application of artificial intelligence or whatever it may be. Maybe it's just automation. But either way, those three steps, that call to action, I think really will help bring the story and the process to reality for a lot of our customers. So With that, we thank you very much. Once again, the replays will be available. You can click on the link that's just come up if you want to go to our website and find out a little bit more about us and look at case studies and real world examples. We very much appreciate your time and your attendance today on behalf of Hiep, myself, and everyone at Turing. Thank you for coming and listening, and we look forward to hearing more from you and talking more with you.
Thank you everyone for joining.
Have a great day.
Until next time.